So today we are going to cover 9.1 and 9.2. Hang on, let me pause for a second. Okay, so 9.1 and 9.2. 9.1 is over what is called the composition of two functions. So when we did 2.4 on Monday, it gave us two functions on a lot of those problems and then asked us to do something with each one of those. For instance, it maybe had us add them together or subtract them, multiply and put one over the other or whatever, several different things. This is going to be something a little different. It's still going to give us two functions. Like number one says, let f of x equal x minus 1. And g of x equals x squared minus 5. And it wants us to find what's called f of g of x. It looks like it says fog. Okay, so when it's asking us to find the composition of function, f of g of x. Oh, wait, it's not x. It's -2. Sorry. My bad. F of g of -2. The very first thing you're always going to do is whatever is in this position. You're going to kind of make that its own little problem to start off with. So no matter what it is, because sometimes it'll say f of g, but sometimes it'll say g of f. Doesn't matter. Whatever is in, you just kind of bring this part down. And that's where you're going to start. So I'm going to start off by finding g of -2. So just like always, whatever this says, that tells me which function to go to. So I'm going to my g function. This tells me what to replace the x with. So I'm going to replace the x here with a -2. So when I do that, I have -2 squared. Bring down my -5. -2 squared gives me +4. Bring down my -5 to get -1. Okay, so again, and remember, if you're going to square in your calculator and it's negative, you need to put parentheses around it, or else it'll tell you -4 instead of +4, like it really is. So once you have completed that task, then whatever this is comes down. So you're going to bring down that f, and you're going to find the f of whatever this solution ended up being. So again, bring this part down, find g of -2, ended up being -1. This now becomes what you're finding, f of -1, because this part comes down. And now you put that in parentheses. So just like always, this tells me what function to go to. So I'm going to my f function, and I'm going to replace its x with a -1. So when I do that, I have -1 minus 1. And if you don't like doing that, punch that in, right? -1 minus 1 gives me -2. Okay, number 2, same kind of problem. Again, it's going to give me two functions. It's going to give me an f of x, which is 3x plus 4. And it's going to give me a g of x, which in this case is x squared minus 2x minus 5. Now, this time, instead of f of g, this time it says find g of f of 7. So, again, whatever is in this position is what you're starting with. So I'm just going to bring that down and find f of 7. which tells me to go to my f function and replace its x with a 7. So if I do that, f function, replace the x with a 7, I'll have 3 times 7 plus 4. 3 times 7 gives me 21. Bring down my plus 4 to get 25. So halfway there, because now whatever is in the front here comes down, and you're going to find g of whatever the first part of the solution was. So I'm finding g of 25, which tells me to go to my g function and replace its x's, right? Since there's multiple x's, where x's with 25s. So when I do that, I'll have 25 squared minus 2 times 25 minus 5. And then if I wanted to, remember, your calculator follows order of operations. So if I wanted to, I could just, instead of doing this in multiple steps, I can type exactly what this is right here in my calculator, which means, let's see, clear it off. So let's see, what do I have up front? I've got open parentheses, 25, close. Then hit your squared button. So there's my x squared. Then I have minus 2. So minus 2, open parentheses, 25, close, minus 5. And then hit enter. It'll follow the order of operations and come up with the solution for you, which is 570. Right? Number 3. F of x is 3x plus 2. G of x is x to the 3rd. And we're going to find f of g of negative 4. So once again, whatever is there, that's where we're starting. So I've got g of negative 4. Tells me to go to my g function and replace its x with negative 4. So if I do that, I have negative 4 to the 3rd power. That doesn't mean negative 4 times 3. If you want to punch that in, punch it in your calculator. Negative 4 times negative 4 times negative 4 is actually negative 64. Halfway there, because now we drop down the front. And I'm finding f of whatever the first part of my answer was. So negative 64. Which tells me to go to my f function and replace its x with negative 64. So if I do that, I have 3 times negative 64 plus 2. And again, I don't want to do that in multiple steps. I'm going to type in exactly what I have. So 3, open parentheses, negative 64, close. Then what? Plus 2. So 3, open parentheses, negative 64 plus 2, which gives me negative 190. All right, number 4. F of x x is x plus 25. G of x is x minus 25. Gonna want us to do multiple things with this one. First of all, it's going to ask us to find f of g of x so just like always, find that first. So I'm finding g of x. Well, it tells me what g of x is. What is g of x equal to? Well, it's just x minus 25. So I'm not replacing the x with a number this time because I'm finding g of x. Okay, so and again, it tells you in the problem what g of x is. It's x minus 25. Now, unlike the last ones, I can't do anything else with this part of the problem, right? Because you can't put those together. They're not like terms. So I go ahead and go to the next step, which is just like the first three problems, you drop down the f. And what are you finding? F of, same as always, whatever the last answer was. It's just not a plain number. The last answer is x minus 25. So that's what I put here. I'm finding f of x minus 25. So what is this telling me to do? It's telling me to go to my f function. Wherever I see an x, I put this in its place. So instead of starting off with x, what am I starting off with? I'm replacing it with x minus 25. So I've replaced the x with x minus 25. Then at the back end, I have plus 25. So I can clean that up a little bit because what happens when you put minus 25 and plus 25 together? They just cancel each other out, right? So you are just left with x. The second part of this problem is the other way around. G of f of x. So this time, so I just flip-flop the f and the g. So this time I'm finding f of x first. And again, the problem actually tells me what f of x is. What is f of x? It's x plus 25. And again, that's as far as I can go with that, right? Because I can't put those together. So I'm going to go ahead and move on to the second half of the problem, which is to bring down the g. And what are you finding the g of? Whatever your last answer was. So x plus 25. So what does this mean to do? This time I'm going to my g function. And what am I going to replace its x with? Well, whatever's in the parentheses, which is x plus 25. So right here where I see this x, I'm going to put x plus 25 and then bring down the minus 25. So just like the last one, when you put together the plus 25 minus 25, you're just going to be left with x again. Now, after you find the answers, which are both x, it's going to ask you to find the domain of each of these and to write it in what's called interval notation. We'll talk about that in just a second. But when remember, anytime you're finding the domain of a function, you're actually looking for restrictions on the domain, like what x cannot be. Because once you find what x cannot be, then x can be everything else but whatever it can't be. Now, The only restrictions we've talked about so far in this class is if you have a fraction, the denominator of that fraction cannot be 0. So here's the two areas when you're talking about the composition of functions and their domains, you have to look in two different places for restrictions. You have to look at the first part of the answer and the final answer. So if either one of these two places has a restriction, that's going to be a restriction on your domain. But is there a fraction here with an x in the denominator? No. Is there a fraction here with an x in the denominator? No. So there's no restrictions, which means the domain is all real numbers. But in this section, it wants you to write that in interval notation. Interval notation is going to have an opening and a closing. So when we're talking about you're talking about all the numbers on the number line. And here's the thing, you're going to have an open parenthesis. When we're talking about all of them, I'm talking about all the way from negative infinity to positive infinity. And both of these have parentheses. Those sideways 8s are infinities. When you're typing this answer into MathLab, it'll have those sideways 8s down there in the toolbox for you to be able to click on to type in your answer. Okay, it's also going to ask you the domain of this one. So the two places I'm looking at are the first part of the answer and the final answer. So once again, no restrictions. So once again, this domain is also negative infinity to positive infinity. All right, number 5. F of x is x plus 4. G of x is 2x squared minus 7x minus 4. Going to ask us all the same stuff. F of g of x, what we're going to find first. All right, so what's in the front? G of x is in the front, so that's what I'm going to find first. Do I know what g of x is? Yes, it tells me right here. G of x equals. There's g of x. So it is 2x squared minus 7x minus 4. So there's the first half. I can't simplify this in any way because none of those terms will combine. So I go to the second part. I drop down the f. And what are you finding f of? What do you put in the parentheses? Whatever the first part's answer was. So I put all this in the parentheses. 2x squared minus 7x minus 4. So I go to my f function. Here's my f. And what do I put in place of x? Everything in this parenthesis. So when I put everything in that parenthesis in place of this x, so I start off, so I have 2x squared minus 7x minus 4. So I replace the x. And then just bring down the plus 4. And I can clean that up a little bit, right? What happens? These two terms right here can combine. One's negative 4, one's positive 4, so they actually just cancel each other out. So all I'm left with is 2x squared minus 7x. as that final answer. And then it's going to go ahead and ask you what's the domain of this. Whoops. When it's asking you what the domain is, remember, you're looking for restrictions in two spots. The first part of the answer and the final answer are the two places that you're looking for restrictions. Neither one of them have fractions, so there's not any restrictions. So once again, the domain of this one is negative infinity to positive infinity. Now I'm going to do the other way around. So I did f of g. Now I'm doing g of f of x, which gets kind of messy. What am I finding first this time? What's the front, which is f of x? So what is f of x? What tells me right here? F of x is x plus 4. So if you wanted to, this isn't your final answer, but you may want to go ahead and star that or something, because remember, this, when you're finding the domain, that's the first place you're going to look for restrictions. So just to kind of make it stand out for later on when we're finding the domain, you may want to just say, okay, or go ahead and tell yourself, well, okay, there's no restrictions on that part because there's not a fraction. So now I need to bring down the g, and I'm finding g of that last part of the answer. So x plus 4. Here's where it gets hairy. Because what does this mean I need to do? This means I need to go to my g. There's my g, and replace its x's with x plus 4s, right? Because that's what's in parentheses. So let's write this out. I'll have 2. Instead of x, I need to write it as x plus 4 squared minus 7. Instead of x, I write x plus 4 and then bring down the minus 4. Now, you've got to follow the order of operations, which means I got to take care of this exponent first. Because x plus 4 squared, I'm going to do it over here. I need to figure out what, I'm going to try to figure out what this x plus 4 squared is. That means x plus 4 times itself. So I've got a FOIL here. Distribute that x. X times x gives me x squared. My outer x times 4 is 4x. My inner 4 times x is another 4x. And then the last part, 4 times 4 is 16. Now remember, I can put these right here together. So I actually just have x squared, put those x's together, so that's 8 x's. Bring down my plus 16. So where does this go? This goes, where did that come from? That was the x plus 4 squared, right? So I'm just going to rewrite this here. And instead of x plus 4 squared, I'm going to write it all the way out. So that'll look like this. 2 x plus 4 squared. I solved over there. So that's x squared plus 8x plus 16. I'm just going to bring the rest of this down. Minus 7 x plus 4 minus 4. I told you this one got kind of complicated. Now, remove your parentheses. How do you do that? You multiply everything inside by what's bumping up against them. So let's see. 2 times x squared. Remember, you just hook them together. 2x squared 2 times 8x, so plus 16x. 2 times 16 gives me plus 32. So that got rid of those parentheses. Now get rid of these. So you're multiplying everything in these parentheses with this -7. So -7 times x is -7x. -7 times +24 gives me -28. Bring down that -4 at the end. Almost there. All that's left to do is clean this up. Are there any other squareds to go with this one? That's the only squared, so I'll just leave it. But I do have some x's I can put together. I can put together that 16x with that -7x. When I put those together, I've got 16 and -7, or 16 minus 7, which just gives me plus 9x. Now look, I can put 32 minus 28 minus 4. Well, what do you get when you do that? 32 minus 28 minus 4. You can just do it all together once. 32 minus 28 minus 4 gives you nothing, right? They just all the way goes away. So these all just cancel each other out. So here's what you're left with. 2x squared plus 9x. So what's the domain of this composition? Now remember, it feels like forever ago, but the very first part we said, okay, let's go back and look if there's any restrictions here or in the final answer. So there's no fractions, so I don't have to worry about restrictions. So the domain of that one is also -infinity to +infinity. All right, last one of this section. All right, this one's complicated. F of x equals 5 over 1 minus 4x. G of x equals 1 over x. Whoops. All right. First thing we're finding is f of g of x. Right? Just like always, we'll start right here in the front. G of x. So g of x equals, well, it tells me what g of x equals. It's 1 over x. So right here, remember, this is going to be the first place that you're going to look for at the end when we're trying to find restrictions in our domain. This is the first place you would be looking. I do have an x in the denominator, so that's going to give me a restriction. So if you want to go ahead and record that restriction, that's probably a good idea, because what can x not be equal to here? X cannot equal 0. Right? Because the denominator, which is just x, can't equal 0. So let's go ahead and just record that for domain purposes at the end. So there's definitely going to be a restriction that the x can't be 0. Now, I've done 1 over x is what that is. So I don't even need to erase that. What am I doing now? I'm bringing down the f. And what am I finding f of? Your last part of your answer. So I'm finding f of 1 over x. So what does that tell me to do? It tells me to go to my f function, which is this weird one right here. And wherever I see an x, I'm going to replace it with 1 over x. So let's rewrite this. In its place of x, I'm going to write 1 over x. So I'm going to have 5 over 1 minus 4. Instead of writing x, I write 1 over x. All right, let's work on this fraction here. I'm going to multiply this right here. So I've got 5 over 1 minus, when you multiply this right here, think of this 4 as being over 1, right? All whole numbers are over 1. And when you multiply, you just multiply straight across on top and bottom. You're not worried about common denominators or anything like that. That's only when you're adding and subtracting. So when I multiply straight across on top and bottom, I get 4 over x. Now, here's the thing. Oops. You can't leave your answer with a fraction in a fraction. So we're going to have to fix that. So what we're going to do is we're going to multiply this fraction on top and bottom by whatever is going to cancel out that denominator. Whatever this denominator is what you're multiplying, the top and the bottom by. So look what happens. If I multiply this, I got to do the top. So let's see what that gives me. Up top, I've got 5 times x, which is 5x. Here's why we did it. Over. So this x, I'm multiplying the whole thing down here by it. This and this. So what do you get when you multiply x times 1? Well, anything times 1 is just itself. So x times 1 is x minus. Here's why we did it. When you multiply this part, the 4 over x times x, this x will just cancel that one. So all you're left with is minus 4, which is your final answer. Now I'm going to find the domain of this final answer. Now remember, I already told myself earlier, because when you're finding domain, you're looking in this spot and your final answer. I already said, okay, one of the restrictions is x can't be 0. This makes another restriction, right? Because x minus 4 also can't be equal to 0. If I get the x by itself, I need to add that 4 to both sides, which tells me x cannot equal 4. So the domain is actually going to have 2 restrictions on this problem because x can't equal either one of those. Because if you replace the x with 0, it'll make this part of it undefined. And if you replace the x with 4, this denominator will be 4 minus 4, which is also 0. You can't have that either. So I have got to write this. It's actually the domain part is multiple choice in interval notation. So the whole entire number line. So think about it like this. Here's your number line. This side goes to negative infinity. That side goes to positive infinity. There's 0. There's 4. I want to include the whole entire number line except those 2 numbers. Those are the only 2 numbers that x cannot be. So where are we starting? We're starting all the way down at negative infinity. And we're going we want to include all of this but leave that open. So negative infinity to 0. Then you're going to see this little u. If you've printed off your sheet, that u in here just kind of means and, or in union with. I also want to say all the numbers in between 0 and 4 are A-OK. So I want to include those also. So that's going to say from 0 to 4 is fine. Okay, I'm not including 0 and 4 because that's what the parentheses are telling me. If the 0 and 4 were included, you'd have brackets. So that's why you don't see the brackets. Now, what else is okay? The rest of this. So also, or and, the last part of the domain would be from 4 to infinity. And luckily, you don't have to type all that in. You're just looking for that answer in the multiple choice. All right. Unfortunately, that's only half the problem, right? We've only done f of g of x. Now it wants us to flip-flop them and find g of f of x and its domain. This is the last problem in this section. The next section is not near as bad. All right, g of f of x. Okay, just like always, find this first. So I'm finding f of x. So remember, the problem tells me what f of x is. F of x is 5 over 1 minus 4x. Now, there's the first half of the problem, right? I am going to have a restriction on this domain. So let's just remember that when we're doing domain. This part is going to give me a restriction. I'll find it later. What do I do now? I bring down the g. And what are you finding g of? Whatever the last part of the problem was. 5 over 1 minus 4x. So what does this tell me to do? It tells me to go to my g function. And wherever I see x, I write all this instead. So let's see. I have 1 over, instead of x being your denominator is 5 over 1 minus 4x. So once again, that fraction is too complicated. It wants me to simplify it. Now, remember what I did on the first part of this problem? I multiplied the top and the bottom by that x because the x is what I wanted to, that was the denominator in the denominator. We do the same thing here. What am I trying to cancel? I don't want to see this. So whatever this is, that's what you're multiplying the top and the bottom by. So I am multiplying the top and the bottom by this 1 minus 4x. So 1 times 1 minus 4x. What happens when you multiply something times 1? Nothing changes, right? So you just have 1 minus 4x in the top. Here's the beauty of the bottom. What happens? This cancels this. That's why we used it. So all I'm left with in the denominator is 5. There's your final answer. Now, the domain part. Remember, you're looking in 2 spots, here and here. This one's going to create a restriction, right? Because I have a fraction and there's an x in the bottom of it. So how do I find this restriction? Whatever that denominator is, say that can't equal 0. I'm finding the domain now. So get rid of the 1. I'm going to subtract 1 from both sides. So all I'm left with here is negative 4x equals negative 1. What are you dividing by? Negative 4. Get rid of this. So what is, I guess this should be not equal, right? X cannot equal the negative over the negative, made it positive 1/4. That's going to be a restriction. Look at this one, the final answer, which is also where I would get another restriction, but look at the denominator of it. There's not an X in this denominator. So this one actually doesn't give me any more restrictions, right? I can't turn that denominator is always going to be 5. No matter what you plug in for X, that's still going to be a 5. There's not an X down here to change it. So this part doesn't create a restriction. Only the first part did. So X can't equal 1/4 is your only restriction. Okay. This part of it's multiple choice again, but let's think about on your number line. I want to include everybody on this number line from negative infinity to positive infinity, except who? Except 1/4. So everything on this side of 1/4 is fine, and everything on this side of 1/4 is fine. The only thing that's not fine is 1/4. So we are good from negative infinity to 1/4 in union with 1/4 to positive infinity. That's the end of 9.1. 9.2. You're going to like this section a lot better. All right, I keep checking chat. I don't see any questions. So we'll move on to 9.2. 9.2 is finding the inverse of functions. And the inverse pretty much just says switch your X and Y, invert them, if you want to call it like that. Now, the first part of this, number 1, just gives me a set of points. It's just trying to get you used to just flip-flopping your X's and Y's. So remember, each one of these points has an X and a Y. It wants me to say the inverse is blank. Type the ordered pairs separated by commas. So just make sure, I should have been here. When you are writing your answer, it'll mark you wrong, right? That's how MathLab is if you don't put the commas in between. So all you're doing is inverting the X and Y. So this is going to turn into 5, -9, comma. Open parentheses, flip-flop, -1, -7, comma. Flip-flop, -3, -5, comma, and then flip-flop the last one, -5, +5. So that's all you're doing on number 1 is flip-flopping the X and Y's. Number 2 says find an equation of the inverse relation. So number 2, it's going to give you an equation. X to the third Y equals -5. Doesn't want you to solve anything. It just wants you to find out what the inverse equation would look like, which again, just means invert X and Y. So I'm just putting these in each other's spots. So that's going to turn into y to the third x equals -5. That's all you're doing on that one. All right, 3, 4, 5, and 6 are all giving you graphs and asking if the function is what's called one-to-one. So it's similar to the vertical line test. Remember, we used the vertical line test to determine if a relationship was a function. And what did the vertical line test say? The vertical line, which is the one that's straight up and down, if you draw a vertical line and it only touches the relationship one time, or the graph one time, that meant it was a function. Now, a one-to-one function, because one-to-one functions are the ones that have inverses. A one-to-one function will pass the horizontal line test. So now we're talking about this line, the one that goes straight left and right. Meaning any horizontal line would only touch the function once. So I'm going to draw all 3, 4, 5, and 6 on the board at the same time, just like I did that on that when we were talking about the vertical line test. All right, let's see what 3, 4, 5, and 6 look like. 3 looks like this. 4. So I can't tell this one. Okay. I like that. We'll talk about that when we get there. Okay, horizontal lines. The ones that go straight left and right. Doesn't matter where I draw a horizontal line on number 3. I'm not ever going to touch this green shape more than once, which means it does pass the horizontal line test, which means yes, that function is 1-to-1. What about this one though? If I draw a horizontal line right here, I touch the graph 2 times, which means no, that one does not pass. So if that's 3, that's 4, here's 5. Again, if I draw a horizontal line there or there, either spot, I touch it twice, which means it doesn't pass the horizontal line test, which means it's not a function. Now, this mess down here, the last one, this is what I'm trying to recreate. I don't know why I can't draw it. But it doesn't matter where I try to draw a horizontal line. You can tell better by looking at this. You're not ever going to touch this graph more than once with a horizontal line. So again, this one does pass. So yes, this one is 1-to-1. All right, number 7. So now what it's going to do is it's going to give us a function. First thing it's going to do is ask us if it's 1-to-1. If it is 1-to-1, it's going to say, okay, then what's its inverse? So the first thing you're going to do is if it says f of x instead of y, you're just going to replace the f of x with a y because f of x and y mean the same thing. So you're going to replace the f of x with a y. The second step is you are going to invert the x and y, which means put them in the other spots. Put the x in the y spot and put the y in the x spot. And the last step is solve for y. Wherever you put wherever your y ended up, you're going to solve for it now. So those are your 3 steps. All right, let's look at number 7. Now I'm going to do number 7. I'll leave this up on the board for just a second while we do number 7. F of x equals x plus 8. Step 1, replace the f of x with a y. So instead of writing that as f of x, just put its equivalent in there. F of x's are y's. So y equals x plus 8. Invert the x and y, which means just flip-flop their spots. So instead of y, I have x equals y plus 8. And the last step is to solve for your new y. I want this y by itself, which means plus 8 needs to go away. I'm going to subtract 8 from both sides. And that gets rid of the plus 8. There's my y all by itself. What's on this side? I've got an x and a negative 8. You can't put those things together. They're not like terms. So you just have x minus 8 over there. There is your inverse. So I forgot to test the 1-to-1. So if you want to test, they're all going to be 1-to-1. You're going to have to find the inverse of all of them. So this x, this symbol right here, that just means the inverse. So that's going to tell me what the inverse of this function is. So the inverse we have found is what? X minus 8, which is what you would put here, the x minus 8. So backtracking, yes, this is 1-to-1. How would I know? Well, I can go to y equals and clear it out. Type in what your function was, which is x plus 8. So here's, remember where your x is. X plus 8, and graph it. Does it pass the horizontal line test? Yeah. There's not a horizontal line is just going to touch that graph one time. So yes, that one was 1-to-1. It did pass the horizontal line test. And then its inverse was x minus 8. All right, number 8. F of x equals 4x minus 6. Okay, yes, it is 1-to-1. It'd be another line. So I'm going to do those 3 steps. I'm going to replace the f of x with y. So y equals 4x minus 6. Invert x and y. So x equals 4y minus 6. Now solve it for where the y is now, which means I want this by itself, which means I need to get rid of the minus 6 with a plus 6. So let's see, what do you have over here? X plus 6 equals, you still have 4y over here. So what do I divide by? 4. And I just checked it. It'll let you do this right here. Over 4. Put that over 4 to cancel that. So y equals, you can just leave this just like this. X plus 6 all over 4. There's your inverse. Number 9. F of x equals 3 over x plus 9. All right, this one's 1-to-1. So I'm going to find its inverse. I'm going to replace the f of x with y. So y equals 3 over x plus 9. Flip-flop the x and y. So x equals 3 over y plus 9. How am I going to get that y by itself? Let's see. The first thing I'm going to do, I don't like it being in the denominator, so I want to cancel this. So that's what I'm going to multiply both sides by. I don't want my y in the denominator, so look what it does over here. It cancels it. So all I'm left with is 3. If I multiply this side by y plus 9, I have to do the same thing over here. So I'm distributing this x. So let's see. X times y is xy plus x times 9 is 9x. So now here's my y. At least it's not in the denominator of a fraction. I'm still having to get it by itself. Now remember, whatever is hooked on is the very last thing that's going to go away. So the first thing I need to do is get rid of the plus 9x with a minus 9x. So I'm going to write what I have left over here. I still have on the left side of my equal sign, I've got xy equals, what do I have over here? 3 minus 9x, you can't put those together. Now, what needs to go away on the left? That x does, right? Because, let's see if we'll let you do this. It's hooked on. So divide them all by x. So this goes away. There's my y all by itself. 3 over x, I can't do anything with that. Minus, what happens here though? Those x's will cancel. There's your inverse. Three more. F of x equals x to the third minus 5. Okay, we're going to replace this with a y. Flip-flop your x and y. So x equals y to the third minus 5. And then solve it. I want this y by itself. So the first thing that needs to go away is that minus 5. I'll get rid of it with a plus 5. So on the left, I've got x plus 5 equals, I still have y to the third power. I don't want to know what y to the third power is. I want to know what y is. The opposite, or the way you cancel out a third power, is by taking what is called the cube root. This right here, this right here, the cube root knocks out the cube power. They're opposites of each other. Like plus is the opposite of minus. Division is the opposite of multiplication. If something is raised to the third power, you cancel it out by taking the third root. I still, if I did it to the right side, I have to do the same thing over here. So like I said, this cube root cancels that cube power. There's your y all by itself. This is what your inverse is. That whole thing. The cube root of x plus 5. Now, you are going to have to type that in. So I am going to share real quick. Let me get to it. Oh, shoot. How you would type that in. Let's see, this is 9.2, number 10. Okay, so you should be able to see that problem now, that x to the third minus 2. When you click in this answer box, down here where it gives you all those things, to type in a cube root, you hit, see there's two different things down here. This is a square root. Any other root, see that little tiny blue box right there? You're going to click that. See how it gives you a little blue box right here? That's where you would type in the cube root and then type in the rest of it underneath. So that's how you type in a cube root instead of a square root. You use these things down here. Okay. All right, two more. Number 11. First of all, number 11, here's what it looks like. And let me explain to you why this one looks a little different. F of x equals 3x squared plus 2, and then it has this, where x is greater than or equal to 0. And here's why. Because when you type this, if you go to y equals, clear it out, and type in this function, 3x squared plus 2, and graph it, look at it. When you see it looking at the whole graph, it doesn't pass the horizontal line test, right? So that's what this little extra is over here. This is saying only look at this function where the x values are greater than or equal to 0. So here's where x is 0, right? Let me go make sure I'm going the right way. So it's only talking about this side of the graph, not this side. Here's where x is greater than 0. All the x is going this way. So it only wants us to look at that part of the graph. So that's why this one is 1-to-1, and that's what that extra stuff means over there. Only look at the graph where the x is greater than 0. So in other words, yes, you do have to find the inverse. So replace the f of x with a y. So y equals 3x squared plus 2. Interchange x and y. So x equals 3y squared plus 2. Now we're going to solve it for this y. This takes a couple of steps. The first thing I can get rid of is that plus 2. I'll get rid of it by minus 2. So on the left here, I've got x minus 2 equals, I've still got 3y squared over here. Now, just like always, I can get rid of that 3 that's hooked on by dividing. So that cancels it. So all I'm left with over here now, I'm getting closer. I still have y squared. Over here, I've just got this weird looking fraction, x minus 2 over 3. Now, remember how the cube root knocked out the cube power? We're going to use that same idea. So what's going to knock out a squared power? A square root. If I square root this side, I got to square root this side. So on the right, it cancels out my squared power. There's my y all by itself. And then this whole thing is your answer. So the square root of x minus 2 over 3 is your answer. But luckily, you don't have to type all that in. It's got most of it for you. You just have to type in the top of that fraction that's underneath that square root. So all you would have to put in was that x minus 2 up there, right? Because it's got the square root and it's got that 3 there for you. It's just missing that x minus 2 right there. Okay, last one. F of x equals the square root of x plus 6. Okay, this 1-to-1, so we are going to find the inverse. Replace the f of x with y. So y equals the square root of x plus 6. Interchange your x and y. X equals the square root of y plus 6. Now, I can't do the minus 6 yet because it's like it's trapped under that square root symbol. So what I need to do first, remember how we talked about what are opposites? Cubes and cube roots are opposites, squared and square roots are opposite. So this time, if I need to knock out a square root, right? I got to knock that out because I got to get to what's underneath there so I can get that y by itself. The opposite of square root is squared. If I do the right side, I got to square the left side. Oops. So on the left, I've got x squared now. On the right, this squared knocked out the square root. That was the point of it. I'm still left with y plus 6. Now that this is released, now I can get rid of that plus 6 with a minus 6. So that gets rid of that. On the left, all I have is x squared minus 6 equals y. There's your inverse. Okay? Whew. Now, hang on, let me pause.